Good afternoon, everyone. I hope you're enjoying the summit so far. And I can see everyone deserting me out there. Behavior analysis. This is what StealthWatch Cloud is about. I'm not going to take too much of your time today. I'm going to spend a quick 30 minutes and introduce you to something we call Cisco StealthWatch Cloud. Why this is important for you guys is that it helps you to monitor the behavior in your AWS cloud instances of what they're doing, giving you visibility. We're looking at the security aspects of what they're doing. Yeah? And we do this with the power of VPC Flow Logs, or Virtual Private Cloud Flow Logs. So like I said, next half an hour, we're just going to cover that briefly. So you might be asking yourself, why is Eric up here talking about this? Why is it important to us? Well, what we're seeing at the moment, I'm sure you guys can see this as well, the threats are evolving. They're getting smarter and smarter day by day. We see in our business at the moment a great increase in the amount of motivated and targeted adversaries we have out there. So, for example, the state-sponsored type of attacks. We see a large increase at the moment, especially in the area that I work in, of what we call insider threats. We see a large amount of people logging into the network rather than hacking into the network, using stolen credentials or credentials that they've gained from social media sites. We also see in our marketplace at the moment that these attacks are getting very sophisticated. The ABTs are increasing, especially the ones that are state-sponsored. What shocks me looking at this slide, if you look at the bottom, is that it takes on average 197 days for us as customers or consumers to detect if there's any potential breach or malware in our network. Then it takes a shocking another 69 days to fix that. That's about 6 months or 6.5 months to know there's something there, and another 2 odd months to fix it. That's costing us on average, or the industry on average, $3.86 million for every breach that we see. In reality, the cost is a lot more than that, but that's just an average. So what do we need? What is required for us to detect these? Well, visibility is a key aspect. If we have visibility, that means we can detect things like crypto mining. That's on the increase at the moment. We can detect ransomware. I'm sure you guys were aware of WannaCry about a year and a half ago. That was big news. But there's other things happening. Shadow IT, rogue devices. Think about it. If you're running an instance in your AWS cloud, how do you know somebody hasn't spun up a machine or instance that you're not aware of that's doing stuff that you need to track? It's all about that visibility. To do that visibility, we need basically a lot of analytical data. We need that analytical data to analyze it and work out whether a certain situation is benign or not. And where's the best place to get that data? Traditionally, it's from the network. What I like to say, my ex-networking guy, you can't hide from the network. At some point, whether it's in the virtual space, whether it's in the cloud space, somebody, good guy or bad guy, has to cross a network boundary. That's where we can get these valuable VPC flow log information and start to track behaviors of those entities. So like I said, the challenge though for us, as you can imagine, is there's a massive amounts of data that we need to analyze. And from that data, we need to find that 1 or 2 interesting events. It's like trying to find a needle in a haystack. But this is where, like I said, especially in our AWS environments, VPC Flow Logs is basically a great saving for us. With the VPC Flow Logs, we're able to track every single host that we see. Every virtual instance that you're running, we will track that. We will know or record their conversation. What I mean by that is we know if instance A talks to instance B, and is that normal or not? We start to baseline their behavior. Like now, I'm baselining everyone's behavior. A lot of you, obviously, you got up and just left now to get a coffee because it's that time in the afternoon. That's normal behavior. That's what I expect from behavioral analysis. I'm doing the same for your network. I'm looking to see what is normal at specific times of the day. Once I can baseline your behavior, I then can alert to any deviation in that. So if I see a specific instance change its habit or behavior, we see that and then we raise a hand up and generate that alert. The key point here is having the tools to tell us there's something unusual happening. It doesn't matter whether it's in the branch, in the cloud, if it's in traditional data centers or networks, we can do that. So the solution we're talking about mainly here is StealthWatch Cloud. Its primary inputs are the cloud-native VPC or virtual private cloud logs. We also can take in native network flow information, like NetFlow, IPFix, or even span data from what we call on-premise networks. So we can work in multitude of environments. That's our primary input into StealthWatch Cloud. With that information, we're able to give you network visibility, network reports. We're able to give you indicators of compromise. We can show you what's happening in the network, and we can even verify policies in your network. Should a certain instance be talking to another instance, as an example. So how do we do it? Well, we use something called entity modeling or machine learning. And this is what I like about the product. For me, being really a systems engineer, it's kind of hands-off. We give it the VPC Flow Logs, and it does all the work for me. With this machine learning or entity modeling, it's going to generate all that great results that we need, or great information. So what it does, what our machine learning does, it maintains, or we build a model of every entity that we see. Now, an entity could be a printer, could be an Android phone, it could be a virtual instance, anything that we deduce as an entity acting on our networks. Once we have that information, that model of that entity, we can understand what the typical behavior is for that specific entity at that specific time of day on that specific day. Like I said, we're using native APIs, and we can use other data sources to basically build that model for us. Here's a slide. We're showing you a bit more detail how that happens. So we can collect data or metadata from various different locations or sources. The main source is our VPC Flow Logs. We really, really like those. But we can get information from CloudTrail, traditional NetFlow, IPFix stuff we can do, traditional networking stuff. We can do IAM logs, watch lists. The more data we put into the model or the machine learning, the more accurate we will be deducing what the entity is and its behavior. We put it into that lovely machine learning. It turns that network data into basically actionable alerts for us. Like I said, being an engineer doing this, I don't have to do anything. I rely on that automated machine learning to do all the hard thinking for me. We then look at the information from that model. We look at 5 distinct scenarios. We look at the role of the entity, the group, the consistency, the rules, forecast. And what I mean by that, if you look at the top one, the role, so if I'm monitoring an entity, say we monitor an entity and we look at that role, we say, hey, that device is a printer. Okay, we deduce that device is a printer. It looks like a printer. It smells like a printer. It quacks like a printer. That's fine. But then if we look at the group perspective, if we see that that printer, is it behaving like all the other printers in our organization? What I mean by that, does the printer all of a sudden communicate to a device outside of our cloud or outside of our environment, maybe goes to a blacklisted country, and starts to send 40 gigabytes of data? There's no way a printer should be doing that. That's not usual behavior for what a printer should be doing. We can also look at what ports and protocols is coming out of those devices. Again, using my printer example, if it starts to use unusual printer ports on the network, we want to know about that. It's obviously not a printer. Again, with the rules, we can define rules. Who should that printer be talking to normally? Should it be talking to countries on our blacklist or not? Things like that. And again, how much data does that printer normally send, and where does it send it? And should it send it? So I'm just using the printer as an example there, but this could be a database server. This could be any virtual instance we have. Yeah. In a bit more detail how we did the machine learning. In this example, I'm just going to show you a very simple database server. Well, not simple database server, what I mean, a learning of a database server. I've split it up in several phases here, you see marked in red. We have the initial, what we call discovery and learning phase. Every new entity that comes on the network, the machine learning algorithm is going to have a look at that. In this particular case, it detects an IP address. It detects what ports this entity is talking to. It still doesn't know what the entity is. It could be a printer. It could be anything. In this particular instance, it deduces that entity is a database server by the ports and who it's communicating to in our cloud. Once it detects that role, it then starts the baseline of behavior. Now, it says here the baseline is 36 days. That's the full baseline. There's a lot of other things we do with entities that require 0 days of baselining. Some require 7, some require 14. But the max baselining we do for any entity is up to 36 days. What that means is we're taking a snapshot of what the entity is doing, and we're learning what its normal behavior is. So that means on the far right here, when we see it doing the normal behavior, we see it talking to the normal locations we expect a database server to be talking to. It's talking to the regular IP addresses or other services it does. In the yellow, however, what we see is that database server all of a sudden start a brand new connection we've never ever seen before. It's communicating outside of our network, and it's sending a lot of data. So that starts to ring some alarm bells to us. That's an anomaly. Its behavior has changed. We need to investigate that. So StealthWatch Cloud will raise an alert and say, hey, we see this particular server, this database server, it's connecting to this other server we've never ever seen it do before, and it's sending a lot of data. This could potentially be some data leakage going on here. Could be. What I like about StealthWatch Cloud is this slide. Again, being a system engineer working with the product, it is low noise. I worked with a lot of systems where you have to tune, the machine learning isn't that accurate, you get a lot of noise, and in the end you don't trust what you see. With StealthWatch Cloud, as I got in a little speech bubble there, if you're monitoring about 10,000 endpoints, entities, the max you will see a day of alerts is maybe 1 or 2 alerts. It has the intelligence to filter out lots of what we call observations that are not necessarily important to us. It's the alerts that we want to action on. And on the right here, we show some examples of those alerts. We have things like excessive failed attempts, DDoS amplification attacks, potential data exfiltration. There's many more than that. That's just a sample. But what I'm very proud of, and the rest of the StealthWatch Cloud team are proud of, is that little icon on the left there with the warning sign. What that means is 96% of our customers find the alerts that we generate useful. Now, being an engineer, I'm not in marketing. It's not a marketing stat. We ask you guys, the users, every time you close an alert to acknowledge it, we actually ask you a question. Is this alert useful or not? You have to say yes or no. You can't avoid the question. Trust me, if you say no too many times, the StealthWatch Cloud engineering team will call you up and say, hey, Eric, why is this alert no good? You keep saying no. So they're watching. It is not just a dumb question or a dumb survey. And they will modify the product if they think what your feedback is, or if that's true, that alert is not useful, they will change that. That's what I like about the product. It's constantly adapting, and they can modify it for us. Some of the stuff that we learn about an identity or resource is we're going to track IP addresses, the traffic from that identity, who it connects to. It's probably a bit hard to see on the screenshot there, but if you focus in, you can see we can track on this particular device. It has multiple IP addresses assigned to it. And the reason why, on the far right, you can see the role. This particular device is acting as an AWS elastic load balancer. So it's going to have a lot of IP addresses associated with it. It's also acting as a web server we reduce. We can see in the middle there, the amount of traffic that it's sent in and out of the network, how much traffic is it's transferring inside its environment, the VPC. On the far right, you might be able to see at the top there, you see alerts and closed alerts, or open alerts, closed alerts, and observations. I want to make a distinction between what an observation and alert is at the moment. Alerts is what we're interested in. Alert tells us, let's go look at that. An observation doesn't necessarily mean it's important to us. What that means is when I'm looking at this entity, this particular device, this elastic load balancer, I'm observing its behavior. Now, the fact that I see it doing a certain action at a certain time of day, it's an observation, but doesn't mean it's an alert. That's normal for that particular device. So you'll see here there's something like 58,000 observations made for this device, but only, about 18 alerts were ever raised for it so far. So again, that's the machine learning helping us here. It's saying I've observed this guy doing lots of things, but that's all within the pattern we expect. But out of that pattern, there's 18 different things it did that we needed you to look at, that we didn't like. Okay. So going back to roles, remember I said on the other slide, the machine learning for us deduces a role for the entity or device that we see. This is quite key. In StealthWatch Cloud, we don't allow you to define your own roles for security reasons. Now, think about it. If I could define my own role, I could make up a server, say, Eric's Fantastic Server, and I could put any software I want on there. That breaches some security guidelines. So StealthWatch Cloud, by default, has over 60 plus defined roles. on the screenshot here, it's only showing some of the active roles that's found in this particular setup. So roles are key to us. And this is why roles are key to us, because we can predict how those devices will operate. So for example, if I have a device or entity that StealthWatch Cloud deduces is a NAT gateway, for example, it says this looks like a NAT gateway, okay. If we see somebody scanning, IP scanning my NAT gateway, that is not as important as if I see somebody scanning a device with the role of database. If I see somebody defined as a database server in that role and I'm getting scanned, that means my databases are being scanned. That's more important for me to action or be highlighted to than my NAT gateway, which is facing the internet. I expect my NAT gateway to be scanned, constantly scanned. That's of less importance to me. So the role is important to us. If we define that role, we know what the device should do, and we know their priority, should I say, or the order in which we should investigate. Other views that we can get from StealthWatch Cloud is one of the new views we can have, what we call network visibility. So it gives you a quick snapshot of the total traffics for the day, how many alarms are being allocated to you, total connection throughput, basically stuff, if you're a networking guy like me, you like to see. The amount of traffic that's sent to devices, how much of that traffic is encrypted. On the far right there, where you can create your own what we call risk countries map, you can define what countries you see as risk, and they will light up if you see communications from those countries. You can also look at top devices, see who the top talkers are basically in your network. Here's an example of one of our alerts. This is a database exfiltration alert. I just want to explain the screen at the moment. If you notice at the top where it says close alert and above, that's the alert itself. The alert that we get from device 15163 is that we see this unusual amount of data transferred from the database server. Below is the actual observation that triggered the alert. Remember I said not every observation will trigger alerts. But in this particular instance, the observation below triggered. The observation is named new high throughput connection. What that meant is there's a brand new connection to some sort of server, looks like it's in the Russian Federation, and not only was it a new connection, it was a lot of data transferred in and out. We want to know about that. Does that mean our database server is potentially being breached and is all of a sudden sending data to places we didn't expect? Other things we can leverage is something called Cisco's Telus threat feed. So within StealthWatch Cloud, we can set up watch lists. In that watch list, we can say if we see anybody inside our organization using Tor exit nodes, then highlight it. So we can create in the bottom there, you see the observations. It's triggered in this particular alert that we've had this host 172.23.3.45, for example. It's accessing one of those, should we say, forbidden or Tor lists. And the beauty with this is we can then spin or pivot straight from that IP address for that host or from the blacklist into the Telus intelligence website. In the Telus intelligence website, we get to see if it's blacklisted. As you can see in this screenshot, yes, it is blacklisted by Telus, but it's also blacklisted by CBL, for example. But the Telus website also gives us like who is the information. It gives us a lot more background information of what those particular Tor entry exit points are. Here, I'm just showing you some examples. This time it's SSH Connections. I see this a lot. When I spun up my own AWS cloud recently, I've got a couple of instances running there. I'm not doing anything particularly sexy, but as soon as you spin something up, I get a lot of these. Everybody around the world is constantly trying to get into my instances. I don't know why. There's nothing sexy on them, but I guess they can use my resources. In this example, we got our AWS instance, and it's constant failed SSH attempts. Somebody's trying to get in. Now, the importance of this slide, what I want to highlight, is not the fact that we can detect that. What I want to highlight is that we can detect this without baselining. Remember I mentioned baseline? We don't have to baseline for 36 days to raise a flag that this is happening. And as I mentioned in red here, this is all about trying to close those gaps, the security gaps in our networks before they become compromises, before they become critical. This is what's key. Yeah. We can also build what we call segmentation rules. So within your network environment or within your VPC environment, we can create what we call compliance rules. We can look at who can talk to who. We can create specific subnets and say this subnet is allowed to talk to this number, or maybe these two subnets are not. We can segment the network that way and generate alarms. Again, let's identify those gaps before they become a problem. We don't need a baseline to do this. So we logically segment our networks. Maybe you have a group of servers or instances that are more critical. Those shouldn't be accessed maybe by a group that's less critical, or maybe a group we allow contractors on, for example. If that happens, we can flag that up and highlight that to you. So how does StealthWatch Cloud work with Amazon? Well, it's very simple, to be honest. In your Amazon web account, all you need to do is create a role with read access and create a policy. And that's the blue box there. Once you create that role and policy, that gives us permission to go into the CloudWatch logs and collect the VPC Flow Logs. Obviously, in the CloudWatch logs, you enable the VPC Flow Logs for each VPC you want us to monitor. StealthWatch Cloud then extracts that VPC Flow Log information through a secure API tunnel, sends it to the StealthWatch console, where it then is put into that machine learning or dynamic engine modeling machine. And then that's where it starts to track the baseline and produce those results we mentioned before. You can also give us additional permissions if you want, where we can read things like Lambda information, config information, or IAM information. It's up to you how much information you want to give us. The more information you give us into that model, the more accurate the model or the machine learning will be. This kind of process, trust me, this is what I like about this, takes less than 15 minutes. I can configure, and I did this recently even on my own lab, a role and a policy, and I had VPC flows in my console within less than 10 minutes. Yeah? Very easy to set up. StealthWatch, one thing about StealthWatch Cloud what I like about it, it's not just about a point application, a point product. We do integrate, and we like to integrate. So we have a bunch of open APIs that allows us to basically integrate with things like SIMs, like Splunk, or other AWS services like SQS or SNS. Also with web platforms like good old Cisco Spark from us, or maybe other applications like email. The point of this slide is that we're all about providing you guys with a solution that can integrate with multiple applications that all work together. That's the key point, work together. You might be saying, okay, how do I get started? Hopefully you are. Very easy to get started. You can apply for a 60-day free trial from AWS Marketplace. You can just simply Google search us. You'll find us on the Marketplace. You can just sign up. Or you can go to Cisco Direct if you wanted to. I would recommend the Marketplace, to be honest. Once you sign up, within about 48 hours, you'll get an automated email saying, welcome to StealthWatch Cloud. Here's your portal. Here's your login details. And you will see a portal very similar to the one up here. Once you sign in, you basically have unlimited users. There's no patching. You never have to do any patching to the system because it's SaaS. It's available anywhere you have an internet connection. Any new features that come out during the trial will be automatically loaded into the back end of the system. You won't even possibly know that they're there. And of course, you get some basic support from our team. Like I said, it's very easy. It takes less than 15 minutes just to try it. Even if you don't want to try it in your active networks, maybe in your home lab or development lab, just try it. Give it 15 minutes and you'll see what you can get out of it. It can be very useful. And I've left the link at the bottom there, but it's very easy just to Google it. To end this presentation, I'm just going to run through a quick demo. And it's just a demo video, so it's about 5 minutes. And it's one of my colleagues called John. He's going through the product to give you an idea of what the user interface looks like and how you can manipulate it or how you can use it. So it's just to whet your appetite and gives you a break from listening to my boring voice. So here we go.
Welcome to the introductory video for StealthWatch Cloud. We're going to cover some common usability tools for the portal, as well as some additional customizations. If you have this screen right here when you first log into the portal, this means that it has not been instrumented yet with network data, and so you should follow directions for either on-premises network or cloud network. Once you actually have a data feed, it'll look more like this dashboard. You'll see any open alerts, endpoint counts, as well as traffic. One of the first things to do when setting up the StealthWatch Cloud portal is to make sure that the right subnets are being seen by the service. If you go to the question mark, subnet report, all the different subnets that StealthWatch Cloud has observed, as well as hosts on those subnets and traffic. You can see it here, as well as enter subnet traffic. So verify that the subnets is correct for your environment. Additionally, the traffic page is useful to see the traffic for your network. So you can see here from February 18th to the 19th, last 24 hours, we have some traffic graphs showing utilization. If you scroll down, you'll see your top IPs during that time period, internal and external, as well as the top ports, internal and external. It's also a good idea to make sure that the traffic aligns with your expectation for your network. If not, it may be that additional sensors are needed. You can see your sensor status up here on this little cloud icon. You can see here we have multiple AWS sensors, 3 premise sensors, and 1 that's offline at the moment. Let's cover another topic here, which is the roles. So as your service begins, StealthWatch Cloud will start to automatically identify different active roles in the network. And so you can see here that, for example, this portal has 10 DNS servers. And you'll click that button, and the 10 DNS servers will be displayed here to the right-hand side. For every device that StealthWatch Cloud has visibility to, you can click the down button and look at the device. This is a summary view for this domain controller. You can see activity for the last month, bytes to, bytes from. So you can easily click this day right here and see who are the spike to in traffic. You can see here as an AMP update, for example. We track different profiles of traffic, connectivity, internal, external, so on and so forth. This is available for every device in the network. You can get to it by several different ways. This is one if you see that drop down I just showed you. Anywhere in the portal, you can click the device. So, for example, here, I can click this device and I'll get this detail. Additionally, you can do a search up here. So you can see 10.201.3.20 is entered. I run this query. I'll now get some details for this, and now I can look at the device here. Additionally, you can see session traffic, which is the ability to search the entire software for certain traffic. So a simple search could be looking for remote desktop activity. I'll type in 3389, leave the default date range there. And so if I run this query, I'm going to see all the traffic that matches my search filter that I entered in here. So these are some of the useful visibility tools in our software. Additionally, as we learn and baseline your software, we'll start to produce alerts. And you can see this portal has several different alerts. For every alert type, you can see excessive access attempts, new external connection, unusual API usage. We'll have what we call observations. Observations are the traffic events that generated the alert. And so for this alert type, we'll see what we call multiple access failure observations. These are connected or external IP addresses that have tried to authenticate to our internal source many different times. Our software detected these attempts and produced this alert. You can see the different IP addresses geocoded to the country flag. For every observation, you can click on the timestamp, and this will actually pre-fill out a sort, and this will be the actual traffic that StealthWatch Cloud observed that generated this alert and finding. You can see all your observations by clicking the observations by type. This is every type of observation StealthWatch Cloud has observed. Some of these will be in alerts, other ones will be just data that we use for our entity modeling process. Lastly is for new trials, it may be recommended to go ahead and do some custom configuration. Everything I've shown you so far happens automatically, but for example, if you'd like to define some of your subnets, you can do that here under the Settings Subnets page. You can also define the sensitivity for a subnet. So you can see here we put some descriptive names which help us troubleshoot this a little bit quicker. Additionally, you can configure your alert settings. So country blacklists, third-party watch lists, like if you want to see every bit of Tor activity in your network, or as well as internal connection blacklists, you can write rules for that, source, destination. And there are other additional integrations you can do that are outside the scope of the introductory video. But if you go to settings, you can see services and webhooks. These are different ways to extract alerts out of your environment, things like Cisco, Spark, or Slack. Hope you enjoyed this introduction video. Thank you.
Thank you. That's all I was going to present.